Hey folks, welcome back to Chapter 1. We're going to do some more graphing in this lesson, but we are going to look at some non-linear graphing. So this is a handout available in the All Resources folder. You can go find it there. What we're going to do is graph some curved lines and talk about how to make them straight lines so that we can come up with a nice easy equation for them using the format y equals mx plus b. So what I want us to do here is we're going to start by just graphing some x and y data on this first graph here. So we're going to label our x-axis as x because that's what it's actually called. Our y-axis is actually called y. You can go and darken these axes. They might look a little bit darker if you've printed this paper out, but I'm going to go do that just because it's a good habit. So we'll darken up those axes for ourselves. Title is y versus x, which means in this case it actually is y versus x. No units to worry about when we're labeling the axes, which is kind of nice. What we will need to do is figure out some scale though. So remember the trick for scale is the biggest number you have to plot. So for example on the x-axis 5 divided by the number of boxes, and I believe there's 16. So that's going to give us on the x-axis a scale of 0.3125. We need to round up to the nearest appropriate number, which will be a 0.5. Now, it's going to be a pain for me to show every single one of those on my axis, so I'm going to show myself that everything is 0.5, and then I'll show the next one as 1, and then I'm actually going to skip a box just to make life easy. So we can easily see that the in-betweens are the 0.5s. We can do the same trick on the other axis. Biggest data point we have to get on there is 75. There are 16 boxes on the y-axis as well. 4.6875. Make sure you round up to the nearest appropriate number, which will be 5. And then I might just count by tens after that. So 10 and then skip a box, 20, 30, and just go on that way because it's going to be hard to fit all those numbers in. Now that we've got this thing scaled, I'm going to pause the video really quickly and plot those 4 data points. You do the same. Estimate them as best you can without little boxes to help you out. Just get them close to the right spot. So your 4 data points should look something like that. And assuming we start at the origin for that, so you can almost put in a 0, 0 just so you don't get confused. That to me sure looks like an upward curve, I would say. So what I'll get you to do just to show the actual curve on there is go draw a smooth line through those points. Don't use your ruler and play connect the dots because that wouldn't be how the object is moving. But it sure looks like a nice smooth curve like that. Now, one of the things you will have to remember from this lesson is how do we make a curving upwards line like that a straight line? And it turns out it's not that hard to do. All we need to do is take the x values. Remember, those are the values that we chose as experimenters, so we're allowed to modify them if we want. We can't modify the y-axis because that depends on nature. And as much as humans like to, we don't really control nature. But we picked these x values so we can modify them as we see fit. And in this case, to take that upward curve and make it a straight line, you're just going to square those values. 4, 9, 16, 25. And now what we want to do is create a second graph down below where we don't touch the y-axis. That stays as is. But we're now going to plot it with an x squared axis. So again, we'll go through all those little detail steps like darkening axes. We would normally have to put some units on those axes. We don't have any to worry about. Title is up, or y versus x. We don't have an x anymore. We have an x squared. So make sure that we reflect that change in the title. Now the y-axis didn't change, so the scale is going to stay the same. Every second box at 10. quickly get that in there. but the x squared axis has changed. So if we grab our calculator, the biggest data point we have to get on there now is 25. 16 boxes. We get a 1.5625. Don't plot with that, but go up, round up to 2. And again, I'm going to skip a couple here. I might go 2, 4, 6, 8. Maybe I'll do this. That's going to be a 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30. And go ahead and plot those data points. I'm going to pause it. You'll just see them there as soon as we get going again. So there you go. 4 points magically show up. Looks awfully straight to me. So this time you can grab your ruler and draw a line of best fit through those. There we go. We've made that data nice and linear. And now what we want to do is find the slope of that line. So we're going to need to create a slope triangle. Now remember, for the slope triangle, you want to make it big. You want to stay away from the data points as well. So I might use that as a spot. And what else do I have? That's not a bad looking spot. If you don't have the nice points where your line crosses over the grid lines, then you can always just pick some other spots and just estimate using your scale. That's fine. Again, you might not. You probably didn't get the same nice spots that I did, just because we have unique lines. And now we want to show the delta y and the delta x squared. I want to show people where we're getting the numbers for rise and run. So the delta y for my graph, and you might have to make your own numbers here or find your own numbers. 65 minus 5. And on my x squared, it looks like 22 minus 2. Once you've got those numbers for your graph, again, they're probably unique to you. We can go over here and calculate slope, which is the rise over the run. So that looks like, what do we got? A 60 over 20 for mine, which is going to be 3 right on the nose. But what I want you to do is I want you to go 2 or 3 sig figs for these slopes. So you can't just put 3, you have to put 3.0 or 3.00. So we want to go 2 or 3 sig figs. Normally we would rely on those uncertainties to help us figure out how many decimal places to use in our normal answer. But since we don't have any uncertainty here, we want to go 2 or 3 sig figs. Don't worry about that information, it's all good. The equation we're going to go with, we're going to stick with the format y equals mx plus b. We don't have a y, oh sorry, we do have a y-axis on this one, my apologies. So y equals m, I want you to plug in your slope, which is probably 3-ish. Doesn't have to be right on 3. That's not even necessarily the right answer. It's just 3-ish. Multiplied by the x. Now we don't really have an x-axis. We changed it a little bit. It's an x-squared axis. And I don't really have a y-intercept, so I'm not going to worry about that. So the equation for this line is y equals 3.0-ish x squared. So there's graph number 1. Let's try the second one. This one is going to be curved as well, but in some other fashion. So I've got 2 columns for you here. They're not called x and y, but what we're going to do is if I give you 2 columns like this, the first column, no matter what we call it, we're going to put that on the x-axis, and the second column, no matter what we call it, we'll put that on the y-axis. So we're going to have a q-axis going up and down, an s-axis going side to side, y versus x for the title, which in this case I guess is q versus s. Darken some axes. No units to worry about again. Kind of cool. Although they're usually there, so keep that in mind. Underline that. And here I'm going to pause the video and just scale this thing out for you just to save some time. These videos are often quite long. Let's try to make one a bit shorter. So I jumped ahead of you a bit. I just did the little calculator trick to scale this thing. So every box on the q-axis came out at 1, in every box on the s-axis came out at 0.5, and then I just skipped some to be able to fit them all in there. Hopefully it's okay, but I did take the liberty as well while the video was paused there, and I plotted the data points. That's what it looks like. And again, assuming that we start at or near the origin, that looks an awful lot like a curved line to me, but now curving downwards. So what I want you to do is draw as smooth a line through that as you can, just to show people the trend in the data, something like that. Don't play connect the dots, because objects don't move all herky-jerky. And critical thinking skills, we had an upward curve in the first graph. We squared the x values. What do you think we're going to do this time to the s values? That's the x-axis that we're allowed to change. What do you think we'll do for a line that curves downwards? Critical thinkers. Oh, good, I heard everybody shout out the answer. That's great. We're going to take the square root of s and plot that on the second graph, and that should make it nice and straight for us. And just to save you some time, I've got the square root s values written down here for myself instead of calculating it on the calculator. That takes too long. 224, 265. So let's get this second graph ready. We're not going to touch the q-axis. That stays as is, but we're going to square root the s-axis. So scaling, nothing changes on the q-axis. We will rescale the root s-axis, but maybe, well, I've got the black pen going. Let me darken those axes. Again, all the little nitty-gritty details, right? Q versus, now it's not s. We want to show people that we've taken the square root of s. And if you go and you run that little calculator trick, the biggest data point divided by 16, the number of boxes, I believe you end up rounding up to a 0.2 on your root s-axis. So I'm going to skip some and maybe just show every one. So that's 2, that would be 3. And again, I'm going to pause the video here for a second and make some data points magically show up. So that one was a little bit less fun, I apologize, but you can estimate where those points go. My 4 data points look like that, which is pretty darn straight. So I'm going to grab my ruler, drag a line to best fit through that. They might not be perfect, that's okay. You want to just sort of hit the 4 data points as best you can. Don't worry about hitting the origin. These lines should all just be close on their own. So maybe something like that. And then we want to make a nice big slope triangle, but we don't want to pick data points themselves. So maybe I'll go with that spot right there. And maybe I'll go with that spot right there. Again, you may or may not get nice points. If you don't have the nice points where you cross over grid lines, just go ahead and pick any 2 points. You can estimate it using your scale. Again, we want that slope triangle to be at least half of the graph, so that one I think is big enough. We want to show delta q's. We want to show delta root s. And it's big minus small. So on mine it looks like 13. Yours might be different though, so pick your own. 13 minus 3. And my root s looks like 2.4 minus 0.6. And once you've pulled your numbers, go ahead and calculate slope. It's going to be rise over run. Don't get it backwards and do it the other way around. So rise over run. So if I go and plug those numbers into my calculator, being careful to use brackets appropriately, I get 5.55555. And we want to go 2 or 3 sig figs on that answer. So I'm going to call it 5.56. Again, 2 or 3 sig figs for all of these slopes when we don't have the uncertainty. 2 or 3 sig figs. So again, the answer is maybe 5.5-ish. If you're between 5 and 6, hopefully, I would say that's probably pretty darn good. And now the equation, we're going to put it in the format, good old y equals mx plus b. We're not going to say y because we don't have a y-axis. We have a, sorry, there it is. We have a q-axis instead. So q equals slope, insert your number, not necessarily mine, might be close, times x. We don't have an x-axis. We instead call that axis root s. And again, it doesn't really look like we have a y-intercept to worry about, so there's your equation. Q equals 5.5-ish times root s. One last curve to look at. I'm going to pause the video and get this whole graph going because now you're getting quick at this and you know the details. So you're going to magically see a whole bunch of stuff show up on there very, very soon. There we go. So I darkened axes. I labeled axes. Remember the first column in the data table, even though we're going to call it something different, we'll put it on the x-axis. Second column on the y. Got my nice underlined title of G versus W. Scaled it out for you. Again, biggest number you need to plot divided by the number of boxes on that graph. And this one, when you go to plot those 4 data points, it's going to make what I hope is really obviously not a straight line. So there's your first data point. I'll just try to do this one quickly. There's your second data point. 3 and 0.67. So it's going to look something like that, which is totally not a straight line. In fact, it's some weird curve that doesn't even approach the origin. It curls out that way. So this one's actually the weirdest of the 3, but that maybe makes it the easiest to remember what to do. Turns out you can make this thing straight, believe it or not, if we take the inverse of the values on the x or w axis. So we're going to take the inverse or the reciprocal of w, so 1 over w, and we're going to plot that graph, another graph, and it should be nice and straight. So the reciprocal of all these numbers, 1, 0.5, 0.33, and 0.167. So we're going to make a second graph. Remember, don't touch the g-axis or your y-axis. That stays as is. But we do want to show that we're changing the x-axis into a 1 over w, which means the title changes. And you'll have to rescale that 1 over w. I'm going to pause the video and get all of that done with the data points for you. So there's our second graph, all plotted. G versus 1 over w, rescaled that 1 over w axis, plotted my 4 data points. Looks awfully straight to me. It actually worked. So we can go ahead and draw a line of best fit through those data points. Maybe something like that. And if we go and pick some spots off the data points for a slope triangle, like maybe right there, and I don't know, where should I go? Let's go way up here. That one's not bad. We'll fudge it and say it's close enough. Make a slope triangle. We've got a delta G, a delta 1 over W. We want to show big minus small. So it looks like 2.2 minus 0.2 and 1.1 minus 0.1, which I think is going to give me a nice answer if I do a rise over run. Make sure you're careful with your brackets. You need to type this into the calculator. And my calculator, if I type that in, it's just going to spit out 2. But be a little bit careful. Remember, we want to go 2 or 3 sig figs. So you actually want to call it 2.0 or 2.00. 2 or 3 sig figs. And our final equation, back into the good old format of y equals mx plus b. We don't have a y-axis though, we had a g-axis. Plug in your slope for m, 2-ish. And we don't have an x-axis, we have a 1 over w-axis. I don't think I'm going to worry about a y-intercept, we're so close. So there's the equation for that one. Now, some important details to remember. You do need to remember what all 3 curves look like and how to straighten them. So to straighten curves, remember we adjust the x-axis. You cannot touch the y because that depends on nature, but you can do whatever you want to that x-axis that you chose. So the 3 curves we looked at in this lesson, ones you'll need to remember. We looked at an upward curve. We looked at a downward curve. And we looked at this crazy one. It actually has double asymptotes, where it's going to get close to the x and y axis but never actually touch. You do need to remember how to straighten these things out. So the first one, curving up, you can straighten it if you square the x-axis. The downward curve, you can square root. I sometimes remember that because does that kind of sort of look like your radical sign? Just without squaring off the corner. Might work for you. And then we've got the crazy double asymptote curve, which is maybe the easiest one to remember because it's so different. We take 1 over the x-axis. A couple of other things to keep in mind. You have to change the name on the x-axis and your title to reflect that second graph when we square root, or take the reciprocal. Change name on x-axis and title. Make sure that you don't use data points for your slope triangle. Go and use the line itself, not the data points. So do not use data points for slope triangles. And when you're doing your slope, this is probably the #1 thing students forget. We want to go 2 or 3 sig figs. If you don't have uncertainty, that's what we're going to say. Go 2 or 3 sig figs. So your homework with this lesson is this document here, worksheet number 5, where you're just going to repeat the 3 curves we looked at. They're mixed up in terms of their order. So you're going to create a first graph. It'll be curved in some way. You're going to modify your x-axis, regraph it, turn it into an equation. You'll notice, though, that there's, whoa, weird. What's going on? There's 4 different graphs, and we only talked about 3 curves. I will give you a hint so that you don't do too much work, that remember, sometimes graphs are already straight. Sometimes they're linear. So what you're going to find in these 4 graphs is that 3 of them are curved. You'll have to do a second graph for each of those. But one of them, when you go to plot the data points, it's going to come out straight already. And in that case, you don't modify the x-axis at all. You just slope triangle your originally or already straight line and come up with a nice, easy equation. So give that a try. Touch base with me if you need help. Happy graphing.